So the last thing we're going to talk about is the concept of partial factoring, and it kind of goes along with what we were just talking about, that every point, the 2 points, any 2 points that have the same y value are symmetrical about the vertex. So the vertex is in between the 2 points that have the same y value. And so what we can do is we can try to figure out 2 symmetrical points that aren't the x-intercepts, because the x-intercepts sometimes are a little tricky. They have square roots in them sometimes that don't work very nicely. So what we do with the method of partial factoring is we just look at the first 2 terms. We pretend this number's not there for a second, and we just factor these 2 terms. We take a common factor out. Okay, so we remove a partial factor. That is, it's partial because it's not in the 10. So we take the minus x out of here. That's the common factor for minus x squared and 6x, and we're left with x minus 6. And then what we do is we determine the 2 points of the function by setting each partial factor equal to 0. So we say minus x could equal 0, or 6 could equal 0. And then we just plug those, when either of those factors is 0, we would get, instead of getting 0, we'll get 10, because there's a plus 10 at the end. So these are going to be 0. And so we have this plus 10. So they both have a y value of 10. So we have these 2 points, 0 and 10 and 6 and 10. They're not the x-intercepts because they don't have a y value of 0, but they are symmetrical. And so we can find the axis of symmetry by taking the midpoint. So we go 0 plus 6 divided by 2, and that gives me 3. And that's the x value of my vertex, right? Because that's the axis of symmetry. And then I plug that in. I plug that 3 back into my equation. So minus 3 squared plus 6 times 3 plus 10, and it gives me 19. And that gives me the vertex. Okay. So that's the method of partial factoring. So if we try to fill this one in, we're going to start by taking just these 2 terms. We're going to pretend the 5 isn't there. Okay. And we're going to say, okay, the common factor there is minus 2 and x. So I take out minus 2x, and I have x minus 4. The 5, again, is staying there. Then I take each of those. So minus 2x, I say that's 0. That means that x is going to be 0. And this one, x minus 4 equals 0, means that x is equal to 4. Now, they have the same y coordinate. They're going to have a y coordinate of 5, okay? Because if I plug 0 in, I'm going to get 0 plus 5. So we have 0 and 5. And if I plug 4 in, I get minus 2 times 4 squared. That's minus 2 times 16, which is minus 32 plus 32. I'm going to get 5 there as well, okay? Just to show you what I'm talking about, if I put 0 into my function, into y, I get minus 2 times 0 plus 8 times 0 plus 5, 0 squared. So that gives me 0 plus 5, which is 5. And then for 4, I get minus 2 times 4 squared plus 8 times 4 plus 5. And that gives me minus 2 times 16 plus 32 plus 5, which gives me minus 32 plus 32 plus 5, and that gives me 5. Okay, so that's where I'm getting those y values from. And then what I do is I say, okay, that's fine. What about now the axis of symmetry? Because I know these 2 are symmetrical, so now I can say the axis of symmetry is going to be 0 plus 4 divided by 2. And that gives me 4 divided by 2, which is 2. So the axis of symmetry is x equals 2, which means my vertex has a y value, okay, of 2. Sorry, an x value of 2, which means then my y value is going to come from going, what's y equal when x is 2? So we go minus 2 times 2 squared plus 8 times 2 plus 5. And we get minus 2 times 2 squared is minus 8. 8 times 2 is 16, and we add 5, and that gives me 13. So the vertex is 2 and 13. And we can then use that information to sketch our graph if we want to, because we know where the vertex is, and we know 2 points. So we can go 1, 2, 3, 4, and then go 5, 10, 15. So there's 15, 10, and 5. This is my y-axis, this is my x, and this is 1, 2, 3, and 4. So we know at 0, it's at 5, so we can draw that one. At 4, it's also at 5. And then at 2, it's up at 13. So my parabola kind of comes down like this and down like this. right? And I know it doesn't look perfect because I'm trying to draw this with a little pen, but that's the idea. You can draw your quadratic, okay? So if we use partial factoring to determine the vertex of each equation, that's all it's asking us to do. So what we do is we say, okay, take this and say, let's take the partial factor out of there. So the partial factor is 5 for the numbers and x for the letters, or the variables. And then I get x plus 2, all right, minus 40 equals 0. And then I say, okay, well then x is going to equal 0. Well, 5x, first of all, sorry, is equal to 0, and then x is equal to 0. Or x plus 2 is going to equal 0, which means x is going to equal minus 2. Okay, now, the y values of those two numbers are the same. So we get our axis of symmetry by going x is equal to 0 plus minus 2 divided by 2, and that gives me minus 1. So my vertex is at minus 1. And then my y value, I'm going to get by plugging this in, assuming this isn't equal to 0, but that is equal to y. Okay? So we have to, these are equations that are equal to 0, so we're trying to solve for the x-intercepts. But if we assume that that's y, then we would go y is equal to 5 times minus 1 squared plus 10 times minus 1 minus 40. That gives me 5 minus 10 minus 40, and that gives me minus 45. So my vertex is minus 1 and minus 45. Okay, if we do same thing here, we would take these two terms. We'd say, okay, the common factor there is x, and we have x minus 7 left over, plus 10 equals 0. And again, we're assuming that that's our y. So we get either x is 0 or x is 7. So our axis of symmetry becomes 0 plus 7 divided by 2, which is 7 over 2. And our y value then becomes 7 over 2 squared minus 7 times 7 over 2 plus 10. That's 7 squared is 49. 2 squared is 4. This is 7 times 7 is 49 divided by 2, and then it's plus 10. And if we want to put those together, we have to put them all over a common denominator of 4. So these guys are going to get multiplied by 2. That 10 is going to get multiplied by 4. So we're going to end up with, if I jump kind of down here, we're going to have 49 over 4 minus 49 times 2. So 98 divided by 4. That's a 9. Make it a little more obvious. And then plus 40 over 40. Or 40 over 4, sorry. So that gives you minus 9 over 4. So my vertex there is 7 over 2 and minus 9 over 4. Assuming again that that's the function, that's just y and not 0 there. All right, so that's the idea. And so you could do some more of those on your own, but that is how you do partial factoring.